Ready to move on to the most famous quadrilaterals, rectangles and squares. You're going to use the properties of a rectangle and a square to solve problems. Rectangles have all the properties of a parallelogram, plus all the angles are right angles. So in addition to having both sides congruent and opposite angles congruent, it is, and consecutive angles supplementary, all of the angles are right angles. The other property that rectangles have is that both of their diagonals are congruent. So if I measure across here and I measure across here, I'm going to get the same length both times. This is actually a really useful property of rectangles. I have used it when I worked for Habitat for Humanity. We would frame a wall, and we knew we had a parallelogram because we knew that the opposite sides were congruent, but we didn't know we had a rectangle, which is preferable if you're building a house. So what we would do is we would measure across the diagonals to make sure that they were the same length. And then we would use a sledgehammer to pound the wall into square position. It's called squaring up a wall. And the way you do it is by measuring the diagonals to make sure you have a rectangle. There aren't very many protractors on a job site, so we weren't measuring the corners to make sure there are right angles. We were using the diagonal property. This is a bonus property. It follows directly from the other two properties, but the diagonals form isosceles triangles. So because the diagonals are congruent, and because the diagonals bisect each other, we know that this is equal to this, and that this is equal to this. So we get isosceles triangles, two pairs of isosceles triangles. We get one here. We get one isosceles triangle down here, matching with the one above, and then we also get an isosceles triangle that is along the side. So we get two pairs of congruent isosceles triangles. Notice that the diagonals do not, in a rectangle, they do not necessarily bisect the angle, but they do bisect each other because they are parallelograms. Okay, squares are even more special than rectangles. Squares have all of the properties of a parallelogram, plus they have all the properties of a rhombus, plus they have all the properties of a rectangle. So their diagonals do bisect each other because they are a parallelogram. They also bisect the angles because they are a rhombus, and their angles are right angles. So since this angle is a right angle, we know that the angle formed by the diagonal is going to be exactly half of that. So we know that this angle is 45. We know that the diagonals are perpendicular because it's a rhombus. So we know that this is 90. We know that this is 45. We know that this is 45. So we get all the angles just by knowing that we have a square. A square has 4 congruent triangles formed by the diagonals. So the practice problems for this section have you using those new properties that we have. We know that this angle is 40, which, because we know that these are isosceles triangles, we also know that this angle is 40 because base angles are congruent. And then we also know, because of symmetry, that this is 40 and this is 40. We know that the diagonals, that the corners are right angles, so we know that this would have to be 50. Notice that the diagonals do not bisect those angles. 40 and 50 are not the same size. And then also notice that the diagonals don't form right angles. They're not perpendicular because it's not a rhombus, it's a rectangle. But we can still figure out what this angle is because this triangle here needs to add up to 180 degrees, so we can figure out that angle, which means that that angle would have to be 80, and so would this one. And then we can also use this triangle over here to figure out that this angle would have to be 100. So those are all the angles in that rectangle. For number 2, we have x's in a lot of different places, so we have to decide which property we're going to use. We don't know anything about the side lengths of consecutive sides of a rectangle, so what we can use for this one is that we know that the angles are all 90 degrees, so we can say, well, 5x plus 5 has to equal 90. So 5x is 85. So x is 17. And knowing that x is 17 helps us figure out what the perimeter is. The long sides of our rectangle are going to be 18 because x plus 1 would be 18. And the short sides are going to be 11 because x minus 6 would be 11. So to find the perimeter, we can add those two up and multiply by 2. So 29 times 2 would give us the perimeter, or 58. For number 3, they told us the length of the diagonals, so we're going to use the property that the diagonals are congruent. So AC, 6x plus 3, and BD, 7x minus 2, have to be equal to each other. So if I subtract 6x, we have 3 equals x minus 2. If I add 2, 5 equals x. Oh, I have some blotches on this one. So for number 4, I have a square, which means that this angle 1 has to be 45 degrees because the diagonal bisects the angle, and the angle is 90. So that means that 2x minus 8 has to equal 45. So 2x is equal to 53, and we're not going to panic because the answer is going to be a decimal. It's going to be 26 and a half, or 26.5. And then if I want to figure out the perimeter, I would do, since all the sides are the same, I would do 4 times 9 times 26 and a half minus 36. And that would give me the perimeter. Number 5, I have a rectangle and not a square, but since I know it's a rectangle, I know that this angle must be the same size as this angle, but those have 2 different letters on them, so I'm not going to use that. I also know that this angle and this angle must form a right angle, so I'm going to do 5x plus 8 equals 3x plus 2. Nope. I had lied. I said it was going to form a right angle, and then I set them equal to each other. That's the biggest thing you want to keep straight in this chapter. I'm going to add them up to make 90 because they are a right angle. And then after I solve for x, I'm going to set 6x plus 2 equal to that angle. I'm going to leave that for you to solve. Number 6, solve for x in the rectangle below. They said AE is x plus 6. They said that DB is 8x. Since the diagonals are congruent, oops, I wrote 86. Since the diagonals are congruent, I'm going to set x plus 6 plus x plus 6 equal to 8x to solve that one. Keep writing 86. I'm not going to finish that problem, but I will post my solutions online. And then number 7, because I know that this is a square, I know that AE should be, if I do 2 times AE, if AE is x plus 2, then EC would also be x plus 2. So I know that 2 times x plus 2 should be equal to 3x minus 10. I can solve for x, and then I can figure out what one side length is. So dA is x plus 1, and then I can find the perimeter from there. And for the last one, number 8, I would use the angle to find y, and then, to find x. So this angle would have to be 45, so 5x equals 45, means that x equals 9. And then I would use the fact that the 2 side lengths are congruent because it's a square to find y. So 5y minus 10 has to equal 3y plus 8. I'll post my full solutions online, but I wanted you to see how these problems would be started. All right, thanks so much. Bye.